We now move into the software side of the SoC. Specifically, we're going to be talking about the video driver. So let's take a look at the code. So I went ahead and I actually generated the bit stream, exported it, created a new Vitis workspace, and included all the files in here. So in the source, you'll see all the drivers for the I/O cores. I also included a couple of new files, which are basically VGA core 8.h and VGA core.cpp. And as it turns out, because of the video cores are not that complicated and they're not as comprehensive as I/O cores, we can include all the drivers in a couple of files basically, or just a single basically class or a single CPP header and its implementation. I also included a new test here. So let's take a look at the driver itself. So the driver itself, again, I'm including all the drivers for all the video cores in here. So I have something we call a general purpose video core, and that's what we're going to explore today. In later videos, we're going to talk about the sprite core to generate like the ghosts and the mouse, and we're also going to talk about the on-screen display to generate silver text on the screen, and another one for the frame basically to draw lines and stuff like that. But for today, we're just going to focus on the general purpose video core. This is basically if your video core is very generic, you can actually just use that particular class as its driver. And if you take a look at what's in it, it actually has the bypass register enumerated in here, which is 2000 hex, which we have basically decided that it's all of them. Like if you want to bypass one of them, you're probably going to see it in here as well, the bypass register. It's everywhere. Okay, just if you want to bypass something, you just go and write one in that particular location. Anyway, the methods for the general purpose video core is actually just a constructor that you give it the base, it just stores the base address. So that because I might use the same class for different cores, you need to distinguish between them using the base address. And then only two functions that you need. You need the write memory, and the write memory basically for the particular general purpose video core or the video core that you're using, specify the address inside it out of these 16,000 rows that are available to you and what value you want to write into it. And that's basically it. So address and color. Okay, and the same, I mean, it's called color. It really doesn't need to be color, but I mean, it's like generally speaking, in a video, you probably all you care about is storing video pattern beside the bypassing in here. Okay, here what we have is the bypass, and in the bypass is just basically whether you want to bypass this particular core or not. If you take a look at the implementation, it's pretty straightforward. I mean, the constructor just stores the base address, and the write memory basically just calls IO write. It's the same exact IO write we have used in the IO cores. You specify the base address, the address within that particular core that you want, and what data you want to write. And in here in the bypass, it's the same exact thing. But now I don't have to specify the address because it's enumerated in the class, which is the 2000 hex in here. Okay, and then you basically just tell it 1 or 0 to bypass that. So if you take a look at the test function, which we're going to explore, we're going to implement this in a separate video. But for now, all I care about is that whenever you need a general purpose video core, you can actually create two objects of the same class. So in here, you do see the test pattern generator, which generates a bunch of colored bars, is a general purpose video core, and the one that converts from color to grayscale is also a general purpose core. Because if you think about it, in both cases, all we care about is whether it's operational or I want to bypass it, and that's about it. There's nothing else that I need to specify, so a general purpose video core is enough for that purpose. You also need to know that basically because it's the same class and we're defining two instances or two classes or two objects out of it, you need to actually know that the base address is actually what makes some difference in here. So I have here is actually basically a video core number 7, and this is video core number 6. And where do I get these numbers from? If you hover over them for a little bit, you'll see where it's coming from and how it's actually computing it. But for really, you can actually go to the header file that we have, which is actually the IO map. It's the same exact one that actually had all the IO cores. It also have the video cores and actually have the different numbers here. That's where it's coming from.